common rates. Okay, so geometric has, these guys will have they're going to have a common rate. And what I mean by that is that you're going to look to multiply it or divide between each term by the same amount. Okay? You're going to look to multiply or divide same amount between terms. Okay. Times 2, times 2, times 2, times 2, times, or divide by -3, divide by -3, or you can write it as times -1/3, times -1/3, things like that. No, squaring is different. Squaring is exponential. It's a different set. Okay. Now, if you think about, then you're talking about it's no longer geometric. It's going to be an exponential function. As the n increases, it goes up. You know, n plus 1. You're taking off quickly. Versus these guys, they're still taking off, but it's just with the common rate. Like I said, these are going to be very, very simple. Look to divide. What I mean by that is this. When we're looking at a sequence, trying to tell whether or not it's geometric, the easiest thing to do is look at second versus first, third versus second, fourth versus third in terms of the sequence. So 2 to 1, divide by 2. 6 to 2, divide by 3. 24 to 6, divide by 4. Is that the same amount every time? No, it's not. Would that be geometric? No. Could you figure out the next terms in the sequence, though? Yeah, you could figure it out. You know, it's times 2, times 3, times 4, times 5, times 6, and so on and so on. That's kind of the idea here. Whereas if I look at one that is, in fact, geometric, divide by 3, right? So you've got 81, 27, 9, 3, 1. You can do this as times 1/3, times 1/3, times 1/3, or divide by 3, divide by 3, divide by 3. I would suggest use the fraction. It's just me, but whatever. Okay, what's that? As it gets to the other, as you go further in, if you have to figure out the next terms of the sequence, it's easier to write fractions right away, as opposed to, all right, 1 divided by 3 is 1/3, 1/3 divided by 1/3 is times, what am I doing? You know, 1/3 divided by 3, instead of 1/3 times 1/3, 1/9. You can, it's quicker to put them together. That's how my mind works. If yours is different, by all means, it's okay. Which is going to give us a way to write out a generic rule and stuff like that as well. So, when we're writing out a terms of generic, blow this up a little bit. And I'll put the geometric stuff on this side. So a sub n is first term, rate to the n minus 1. Rate ratio, think of it as R is that common ratio. The difference, it's, and I don't want to say difference, it's the common multiplier. So this a sub n still stands for the nth term. A sub 1 is still the first term. And R is the common ratio. Common rates, whatever you want to call it. Multiplier, divider, and then we're up. I don't know if you can tell. What's that? All right. So if I want to write that real easy sequence of 81, 27, 9, 3, and 1. What's my first term? 81. What's my common rate? 1/3. So all I would do is this. Oops. Same thing, isn't it? 1 divided by 3. Yeah, they are relatively straight. Yeah, homework. No, I'm kidding. Oh, and by the way, the PDF file has already been checked and it does work already. So, have you ever even used the fax machine? Oh, okay. All right, let's write the rule and then find the 8th term. You know, there are some things that you still have to fax, which I think is just stupid. Yeah. Nth term, first term, common rate, n minus 1. What's your multiplier? 3 halves. If you look at it, if you start thinking about what your multiplier is, always go second to first, third to second, fourth to third, 12, negative 12 over negative 8, negative 18 over negative 12, negative 27 over negative 18. All of those fractions will simplify out to being 3 halves. Okay, that's how you get your rate. Nth term, negative 8, 3 halves, n minus 1. Bless you. Which means I got to find my 8th term, the 8th term. And lo and behold, you have a calculator that is your friend. Once it loads. Did you check it twice? Did you figure out who was naughty or nice?
No, it's stuff I'm gonna embroider.
Oh, that's cool.
And then on my shirt gets me and you smell delicious.
Like you do.
I know, right? In all caps.
All right. In these guys here, there will be parts that will ask you to graph the sequence. You might have seen a couple of those the other day. I'm not going to ask you to graph these things by hand. You can look at the graphs on the calculator. A lot of times the graphs will help you identify what a certain value will be later on. We have graphing calculators that allow us to do that. So if it ever says graph, you don't really need to. It's going to be more along the lines of, hey, that means you probably just have to press y equals. One of the terms of geometric sequence is the 3rd term, and it happens to be 5. And the common ratio is r equals 2. Let's write the rule for the nth term, which means what do you have to solve for? The first term. Okay. So again, you'll notice it will have some algebra moving back and forth. So we write out the generic formula. The nth term is first term r to the n minus 1. We know that the 3rd term is 5, which means that has to equal the first term, the rate of 2, and then this will be 3 minus 1 up here. Remember, the n value is represented by a 3, so everywhere I see an n, I put 3. The nth term is 5. That's why I say that a sub n is now 5. So now you have to walk backwards here to figure out order of operations. My brain says 3 minus 1 is what I should do first, and that is 2. All right, 2 squared, 4. Okay, so now we have this really difficult equation of 5 equals 4a sub 1. 5/4 is your first term, very good. So you get your nth rule, 5/4 times 2 to the n minus 1. Yes, ma'am. Sure. Absolutely. There's so many ways to go about doing these things, and if you find a shortcut that works easier, go for it. I'm not going to say no. Absolutely not. He will, but his voice doesn't really matter as much. Not to say your voice shouldn't be heard. Your voice is important to all of us. What? 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 I can't hear you. What? What? We'll get there. No, when you start looking at patterns, how to write rules for patterns, if you think about, we'll get to like honeycombs as things build out. How many more does it grow outwards from like the 6 side? Then all of a sudden you have 6 sides, have all those extra 12 sides, and it has more and more and more. When you go through there, seating, you do calculations for seats in a theater. You have less seats up front as it widens out. Yeah, there's a problem like that in the textbook. No, I don't think we will. 2 terms. If 2 terms of geometric sequence are, the second term is 45 and the 5th term is negative 1215, let's write the rule for the nth term. Now, when we do this one, again, I'm going to start by setting it up as a system of equations, very similar to what we did before. What's going to happen is we're going to use substitution into one for another. It seems like it takes a lot of time to do it, but in essence, this actually does work rather quickly. So we start by writing the rules. If that's the generic, I know that the second term is 45, which is the first term r to the 2 minus 1. And then I have the 5th term, which is negative 1215, which is the first term r to the 5 minus 1. What this is going to allow me to do is this. I know then that 45 is the first term times the rate. I also know then that negative 1215 is the first term times r to the 4th. When I get to these problems, what's going to happen here is that you're going to have your first term and your rate in both equations. What you want to do is isolate the first term. I'm going to take 45 and divide it by r. Okay. By doing this, I can then take this and I can substitute into here. Because it's going to allow me to rewrite it in terms of just one variable, and I get r to the 4th over r, which allows me to simplify that. You always want to get, when you're doing these, you want to isolate the first term. Okay? That's going to be the trick for this. So you get negative 1215 is going to be 45 over r times r to the 4th. What does that simplify to being on the right-hand side then? 45r to the 3rd. Okay. if you solved for, got r by itself, you can, but then you'd have to take r, if I'm saying that 45 is going to equal, 45 over first term equals r, then I'd have to fourth it. So you want to get rid of, you don't want to deal with ones that have extra variables. So this becomes negative 1215, 45 r cubed, divided by 45. Do this right. 12, oops. There we go. And now negative 27 equals r cubed. What's r? Negative 3. What's that? You just trying to be a pirate? So your rate is negative 3. If my rate value is negative 3, what do I do then to find my first term? Very good, Sarah. I take it back here, and I get 45 divided by negative 3, and I get negative 15. So this works out to be, basically it's a substitution problem twice. And then you can write out your rule. The nth rule is But if you really think about it, none of this is any harder than really anything. I mean, it's okay. It's okay. Seriously, it's okay. All right. Let's see. I think we got time to get the other one done real quick. Series. Geometric series. Find the sum of a series. Okay. So when we have the sum of a series, again, we'll have the same idea. We're going to have, you'll be given a series. You'll have to figure out what the rate is, all that. And then we'll have to figure out the sum of so many. And then we'll also do the same thing we've done before, where how many do you have to add together to get a certain value. So it's not going to be terrible. It's just some algebra. For example, consider 1, 5, 25, 125, 625, and so on and so on and so on. I'm considering this as well. 2 parts. Find the sum of the first 10 terms and find the number of them that you have to add together to get 3906. Yeah, this one has a couple extra steps to it, but it's not terrible. It's not squaring, because if I squared 1, it would be 1 plus 1 plus 1 plus 1 over and over again. So your first term is 1, and what's your rate? Times 5. So what we do here is we're still going to figure out what the nth rule is, because we know, well, actually, the nth rule is first term r to the n minus 1. So that's 1 times 5 to the n minus 1. Well, that's pretty easy. If I need to find the sum of 10 of them, the sum of 10, that's going to be the first term, 1 minus the rate to the n over 1 minus the rate. Well, our rate was 5, and how many do we have to put together? 10. So, put it together. We know then that the sum of 10 is 1 times 1 minus 5 to the 10th over 1 minus 5. Again, go right to the calculator. Do I need to really worry about that 1 out in front? I can just create the fraction bar and put it in. So if I do a fraction bar, alpha y equals 1 minus 5 to the 10th over 1 minus 5. 2,441,406. Okay. Sure, I'll write you a check. I didn't write my check. Just who writes checks. Not really. I know, but most things you just press a button, it's paid. And, well, I still, I mean, there are times I don't automatically pay my NICOR bill. I mean, I pay it, but I don't like pay it online. Reason being, NICOR charges you to pay online. What? Stupid. It's a convenience fee. No, it's not convenient. It's not a convenient. I should pay $2.50 extra a month to press a button to have a wire transfer that costs you nothing. I'm going to mail you a check and make you have to open it. I did. Yeah, some places they do that. They charge because they have to pay back. They have to pay the credit card month company's fees to do all that. This is the weird part. Find how many you have to add together so that you get 3906. So find n. We knew that the rate was 5 and our first term was 1. Okay. Now watch what happens here. So if you put this together, you get 3906 is going to equal your first term, which was 1, times the quantity 1 minus your rate to the n over 1 minus your rate. Are we okay with that? Bless you. Since my first term is 1 in this case, do I need to worry about it? In the parentheses, can I simplify anything? I can only simplify the bottom. I can simplify the bottom to get -4. Everybody okay with that? So I get 3906 is 1 minus 5 to the n over -4. How do I get rid of the -4? Multiply both sides. So I take 3906 and I multiply it by -4 and I get 15,624 equals 1 minus 5 to the n. Now I need to get and solve for an exponent. How do you solve for exponents? Nope. Well, first thing I want to do is I want to make that base positive. So I'm going to add 5 to the n to the left, and I'm going to add 15,624 to the right. So I get 5 to the n equals 15,625. How do you make an exponent drop? What rolls downstairs comes over in pairs, rolls over your neighbor's dog. What's fit for your snack? It fits on your back. It's log, log. It's log, it's log. It's big, it's heavy, it's wood. It's log, it's log. It's better than bad, it's good. You're gonna love it. I added this over, so 1 plus that. So you have to do a log base 5, which is easy. $15,625. Yeah, $15,625. And that's the thing. Some of them are short where you can do that. That by all means, if you see that's not a lot of them to add together, go for it. But I'm going to make sure you have to press buttons. It's not tough. It's just the fact that you forgot how to use log. This is the time. This is the only other time in this textbook that we actually wind up using logarithms. And really, that's all you have to do is when you have whether it's 5 to the n, 4 to the n, 3 to the n, whatever, you log base whatever that is, and that's how the exponent drops, and you take it to the other side. And that's how you get your integers. Remember, this value of n should always be a countable integer because you have to be able to add up like 6 of them or 8 of them, not 6.6 or 2.3. That would be bad. Well, 7 you can add together. Yes, that's okay. You can add 8 of them together as well. That's so what I say this was 6. Now, one of the things that we've changed throughout the past few years with sequencing kind of the notes and stuff here is that when Common Core first hit the high school about 3 years ago, I want to say, yeah, it's about the third year of it. This unit was the first section we were supposed to start the school year with. So I had already done arithmetic sequences. I started doing geometric, and then all of a sudden I had to show you guys how to do logarithms, solving for exponents. Basically, on the second week of school, I was trying to show people how to do this. They're like, what? And then I said, you know what? I'm no longer going to follow Common Core sequence order because it makes no sense. That's how I roll. I'm a rebel. I'm something. There's a great picture in the textbook. I don't know how well you can see that. She's on a cell phone, and that cell phone was quite literally about the size of this, because this was the size of the phone that one of my first cell phones was about that large. What? Got him. My parents had a 1989 Mercury Cougar, pretty sweet, and it had a car phone mounted on the side with a cord. Because I don't know, my parents must have been, really important people that had to have a cell phone in their car. I don't know, but yeah. I saw that picture. I'm like, all right, I'm pretty sure I had that phone. I think it's a giant Primeco phone. Primeco. Hey, you see this phone? Look at this one. Look at this phone in the book. Look at that size of that thing. It's like a Primeco. Yeah. Scale that, size of your face. What an antenna face phone. Well, here it is. Antenna face phone. Hello. And then you do this. I have a banana. Hello. Do those. Yes, sir. No, yes. I didn't personally, but my parents did. When they did, I don't know. My parents were always big on technology. They always thought it was really cool to get the new stuff, and they just did. We did have the giant bag phone, and then we got the bag phone didn't work very well. The battery always died, so I think they got rid of it. But this is before the day that you had to have all these different cell phone plans. You just basically paid for the minutes that you used. So they had that, and then I got the Primeco phone, which Primeco was a big deal, and then AT&T bought them out, so the AT&T wireless took over them. But they got one of those Motorola StarTAC phones. I don't know if you ever heard of those. They were like one of the original flip phones. So it was probably, I'd say, can I steal your regular phone for a second? I think that the StarTAC phone, when it was unfolded, was about this big, but then it had the antenna on it. So it had about a 5-inch antenna on it, and it would fold up, but when it folded up, it was probably about 3 of these thick, I'd say, when it was folded up. So, but yeah, it was awesome. I think, if I'm not mistaken, I think that was also one of the first phones that had text capability. But you, instead of like having letters like you have now, you had your alphanumeric buttons where to get, so to type the letter J, you'd had to hit 5 like 4 times. And yeah. Yeah. So we had those, but after that one, I think the next generation of phones had like blackjack on your cell phone. Then all of a sudden you're playing like, yeah, I had a Nokia with that. That was awesome because we had an Intellivision set. which was they had steak on that. It was so slow.
Exactly. I miss I don't like we had stuff like that.
All the cool kids did.
We don't like we never had volleyball.
No, the cool kids.
We had those like huge.
Oh yeah. Oh yeah.
And
Yep.
you can't get rid of them anymore.
Oh, you can't. You're like.
So we have like 3 of them in our garage. We don't know what to do.
I think the county will take them away